We'll begin with our quick look at the calendar. Today is March 5th. We're spending 2 days in this one section here talking about applications of systems. So these are going to be all word problems that we do today and next class. And once we translate all of the word problem into 2 equations, then we use the techniques that we learned last class to solve those 2 equations, the system of equations. So that's today and Friday. Coming up on Monday of next week is our review day, and then Wednesday of next week is our first exam. We only have 2 exams all semester. One of them is coming up on Wednesday. Questions on the calendar? Okay. So on page 76, I'll jump up here to number 1, and we'll begin with Victor. Right, so I think part of the issue, people always talk about I'm bad at word problems, the language, word problems, like who wants a problem? But opportunity is something we can embrace, right? So story opportunities from this point forward, no more word problems. All right, Morgan, number 2. Okay, go ahead. Great, thank you. All right, so number 3, let's go back to Tim. Okay, so let's give this one a shot. Suppose that we just had candy that was $2.50 a pound, and we don't have this other more expensive candy, just the cheaper stuff. So if we make a 5-pound bag just of the $2.50 per pound variety, how do we figure out how much to charge for that 5-pound bag? 250 times 5, right? 250 per pound. Okay, so let's just do that real quick. So if I do multiply this guy by 5, what is that? 10, is that $12.50? Okay, so that's what we would charge for a big bag of just the cheaper candy. What if it were just the expensive candy, but still 5 pounds? How much would that cost? That'd be 20 bucks? Yes? So do you buy that if we mix and match these 2 kinds of candy, the cheaper stuff and the expensive stuff, that we can make a 5-pound bag that's worth really any dollar amount between $12.50 and $20? We buy that? Right? If you just do the cheap stuff, it'll be $12.50. All expensive stuff is 20 bucks. And then we can just mix and match and get every number in between those 2. So in particular, $17.60 is achievable. It's a number that's possible. Is $17.60 closer to $12.50 or 20? It's a little bit closer to 20. So does that mean we're going to be using more cheap candy or more expensive candy? More expensive candy, because we got to lean it towards the 20. But it's not going to be all expensive candy. So that's just like a little intuition look at what's going to happen here. So step 1 is to define variables. Oftentimes this is a step that stumps some folks. And people try to just dive in and start writing equations. Well, we can't get equations until we have letters that are meaningful to us. And there's a big hint, which I think I've shared this with some individual groups, but I haven't said this to the class as a whole. But if you want to define some variables for almost every word problem, story opportunity that I give you, just look at the question, the very last part of it, and I am telling you what I want those variables to represent. How much of each type of candy should be included? There's 2 variables described in there. There's how much of the cheaper candy and how much of the more expensive candy. Okay, how much is kind of a wishy-washy phrase. What's a better way to really quantify what we're trying to count here? How many pounds, right? That's what we're trying to do. So let's come up with our 2 variables. We can call them X and Y. We can call them like cheap and expensive, C and E, whatever we want to do. What do you guys want to do? X and Y? Okay. So let's let X equals the number of pounds of the cheaper candy. And then we'll let Y be the same thing, but the more expensive candy. Okay, so we've got two variables, and I cannot overstate how important it is to really pause when you're faced with a new word problem and think about what variables you might choose. The big hint is in the actual question itself. All right, we're going to organize our info in a table. It could be many of you don't need the table at all, and I'll never force you to fill in the table. You might be able to just jump to equations right now, but we're going to fill in a table. So the first thing we need is the number of items for candy type 1, the cheaper stuff. What letter did we choose? X. I mean, it says number of items, but it's really number of pounds, right? This is kind of like a generic table, not specific to this problem here. And then the number of type 2, I guess we can put a Y there. Okay, and then the total. Now, you could just say X plus Y, and that's a good way to think about it. But generally, the stuff in the bottom row here is just numbers from the problem, not variables that we made up. So what's the total number of candy? Is 5 what? 5 pounds, right? That total is the total weight that we're interested in here. So we're almost always going to be putting numbers in that bottom row from the problem. Okay, next column is the cost per item. This is usually the easiest to fill in because it's all given. The first candy, what's the cost per pound? It's $2.50. And the second candy is $4. Sometimes I get fancy and I put like a big X through that last one there, but the cost per doesn't make sense in terms of a total. So we're not going to put anything down there. It's not applicable. Okay, and then we get to the total value here. So when we knew we wanted, for example, 5 pounds of all the cheap stuff, we just knew to multiply the number of pounds, 5, by the value per pound, right? The 250. So it's the same thing here. It's still 250 per pound, but we're not doing 5 pounds of candy. We're doing X pounds of candy. So do we buy just 2.50 times X? 250X. Is that all right? Okay, and then the same thing here. Total value for candy 2 is 4 times Y. If you're just a rote procedure type person, I guess we can say that the last column here is just the product of the first two. That's the way it works when you read these tables. Okay, and again, down here in the total, I don't want to put variables. I want to put a number from the problem. So what's the total bag of candy supposed to be worth? $17.60. So we put that there. Questions on filling in the table? And then once we've got the table, the equations should kind of fall out. So to find the equations, we're just going to look in the columns of this table. So what's the first column? What equation comes out here? X plus Y equals 5. We have X pounds of the first kind and Y pounds of the second kind and 5 altogether. So I'll write in green here, X plus Y equals 5. And then we'll skip the purple column. There's nothing to write down from that, but the last column we can. It's the same pattern as before. That's it. Just adding up those first two and setting it equal to the last. Questions on the equations? Okay, so this is now done in terms of the word part of this problem, right? It's just now like plain old naked equations, and we solved plenty of equations last class, right? Like this looks familiar. So I'm actually going to stop this problem here, and maybe like right at the start of the group activity, you guys can come back and just finish this one, just solve it so that you have an answer. One thing I'll say, if you don't like decimals, what could you do to that black equation to get rid of all the decimals? Times it by 10, right? So multiply by 10 if you want to. That would get rid of all the decimals. Okay. Okay. Any questions on this problem? Okay, let's go on to the next page. There's one other problem I want us to do together, and it has to do with money. So first, a little bit of vocabulary. I'm going to go back to Lauren for number 4. Okay, thank you. Yurka, for example. Simple annual interest. Okay, do we know how to do this? 2,400 bucks, it's invested for 1 year, and you get 4% interest. How do we find out how much interest we get? What do we do? Yeah, I guess there is an equation, so I'm asking if we know, like, what is it that we have to plug in or calculate to get this answer? Right, so I'm going to write here, interest is equal to 2,400 times 0.04. That's right. You are getting 4% of whatever you put in the bank. And that of in a math class almost always means multiply, so we multiply 2,400 times. And then Alan did something really smart. What did he do? It's not 2,400 times 4. What did he do? Yeah, percent into a decimal, right? Okay, so we get whatever we get here. What do we have? 48.96. I think that's right, $960. The important thing isn't the number. The important thing is this formula that we just kind of figured out here, is that if you want to find the interest I, then you take your principal and you multiply it by the rate. Now there's another letter that's often in this formula, and that's T for time, like you multiply by the number of years. All the problems that we do here are going to be just 1 year, and multiplying it by 1 doesn't change anything. So we're going to use a simplified version of that equation, just this guy. All right, so let's come down here and look at number 5. Karen, can you start with the Jerry? Okay, so a different looking problem than the candy problem, but it turns out it has a lot of similarities to the candy problem. So let's start by defining some variables. Where should we look to figure out what our variables should represent is the question. Very last part of the problem. So what does it say? It says, how much did he invest at each rate? So I want to know how much was invested at the 4% rate and how much was invested at the 9% rate, and those are my two variables. So do we see that we can really use that last part of the problem to get our foot in the door? Defining variables is a really important step, and it's given to you if you know where to look. Okay, so it seemed like we're interested in X and Y, so we can do that again. Let X equal amount invested at, and I'll just pick the first number, 4%. What are the units here? Dollars. And then we'll let y be the other one. Okay, let's start filling into our table. Amount of money invested in bank one, which I guess we'll let bank one be the first bank, the 4% bank. So we picked a letter. What letter did we pick for the amount invested? Is X. And then in bank two is Y. So actually this table so far looks exactly like the candy table, right? We had an X and we had a Y. And then we want a total. You could say X plus Y, but again, we want numbers in that bottom row. So the total is going to be in the problem. How much was invested in total? $2,000. So that goes there. And even at this stage, you might be ready to write down an equation from that column, right? What's the equation from that column? X plus Y is 2,000, which makes sense. We didn't need a table for that equation. You invested X and you invested Y. Altogether, it was 2,000. Okay, the interest rate. This column is all going to be given in the problem. What was the interest rate in the first bank? 4%. I'm not going to write 4. I'm going to write 0.04. Because I know the numbers in this table are going to give us equations. And equations aren't allowed to have those percent numbers in there. Got to change them to decimals. At bank 2, 0.09. Total, it's actually the same thing we wrote in the candy problem. What did we put down here? An A. The total percent interest doesn't make sense. It doesn't have meaning. Okay, now this is the new column, the hardest column. Amount of interest income. All right, let's come back to our equation right up here. The formula for the interest was the principal times the rate. That is the amount of money you invest times the interest rate. Yes? In that first row, what did we call the amount of money we invested? It's X. That's what we called X, right? The amount we invested in the first bank. Again, it's principal, the amount you invest, times the interest rate. What was the interest rate in that first row? It was 4% or 0.04. So what do I do with the X and the 0.04, which represent the principal and the rate? Is we multiply them. So it's just X times 0.04. Do we see it? Just taking the principal, multiplying it by the interest rate. How does that compare to the candy table? It's the same. Isn't it exactly the same as the candy? In the candy, it was how many pounds of the cheaper candy times the price per pound. Here it's how much money did you invest times the interest rate. So even completely different contexts can oftentimes end up looking exactly the same when you break it down. Okay, what goes in this second row here? 0.09y. Okay, then we want a total. Total in this column has everything to do with interest. Did the problem tell us what the total amount of interest he earned for the year was? It didn't. If it did, we would just put that number here, like if it said he made $170. But it didn't say that. So actually total is kind of a misleading thing because total is not relevant to this problem. So I'm going to put like a slash here and write relationship. Because sometimes instead of giving a total, we're given some other relationship in the problem. What's the only other number we haven't used in this problem? Is the 37, right? We know that one investment was 37 more than the other. So I'm going to put an NA over here too because total doesn't make sense, but we are going to write that relationship as an equation. Again, it said here $37 more in the one investment, the high investment, than the low. All right, we got to somehow write that as an equation. Okay, so the equals. One of them is 37 more. What is that going to translate to? So plus 37, right? One of them is 37 more than the other. We got to figure out which one goes where, okay? I'm supposed to either fill in the low interest amount or the high interest amount. Which one goes with the plus 37, the low or the high? It's the low. Oftentimes people get this backwards. So I'm going to write this in kind of English, and then we'll change it to symbols. But this is the correct order. You take the low interest amount, you add 37, and that builds up to the high interest amount. Oftentimes people say, oh, the high one is the one that's 37 more, so they'll put the 37 with the high. But that's not right. Because without this guy here, this is definitely not true. To make it true, we have to build up the 37. You don't need to add to the high, you need to add to the low. But the amount of interest we got from the low is exactly this 0.04x. That's what that represents. So this is 0.04x plus 37 equals the high, 0.09y. So that's the relationship. Alan. .09y minus 0.04x equals 37. Let's translate this into lows and highs. What is this 0.09y? That's the high. Amount of interest you got from the high minus the low. It's 37. Do you buy that? Does that capture that the one is 37 more than the other? I'd say either one. The blue one might be better in that the x's and y's are on the same side, and if you like that, then go with the blue one. Yeah, Alan's equation is perfectly legit. Another way to say that the one is 37 more than the other is that if you subtract them in the right order, you get 37. So either way is okay. All right. Okay, so I'm going to stop this one right here because we now have our two equations. I'll circle this one here, but you're welcome to use the blue. So those are the two equations. Again, if you don't like the decimals, what can you do to that second equation? Multiply by 100, right? That would get rid of all the decimals. So here's what we're going to do. So we did two problems together, but we didn't finish either of them. So what I'm going to ask you to do in your groups right now is you're going to finish this problem, find x and y, and then write a little sentence. Then go back and finish the candy problem and write a sentence. And then go forward to where the group activity actually starts. There's a list of stuff all written out. This is just for your reference that you can check out later. It kind of summarizes what we did a little bit more formally. And then there's this group activity, and I'm going to ask folks to start in different places. There are 5 different problems here. I don't know if we'll be able to get each group to do all 5, but at least each group will do a few of them, and we'll get all the solutions up here by the end of the class, okay? So I'll tell you where you guys should start, but begin with finish the interest one, finish the candy one, and then jump here.